We're talking about electricity. We're going to talk about charge to start with, and then we're going to talk about circuits. So, hopefully maybe it'll keep you from killing yourself, doing the wrong thing, but let's talk about charge. With charge, we should know this from like 4th grade, right? That the same charge, like charges repel, opposites attract. Okay, so if you have two positive charges, they're going to fight away from each other. If you have two negatives, they're going to fight away from each other. Yeah, you don't have to, really the idea here, too many, that means electron. So too many electrons will give you a negative charge. So somehow you got an extra electron on something, it's all of a sudden negatively charged. If you had a negative, or if you lost one of the electrons, you take a balloon, you rub it in your hair. One's going to be positively charged, one's going to be negatively charged. Okay, all it is that electrons got passed from one to the other. Okay? Okay, so, but you should know from before, like charges repel, positive and positive will repel, negative and negative will repel, and opposite attract, right? We know that already? Alright. Do we need to pause for a second?
Yeah.
We're on? Okay. Okay. Now, understand again, charge is not destroyed or created. It's just going to be that electrons are passed back and forth. Okay, that's the way everything will happen. It just causes, there's different ways to do that. With electricity, for a long time, the only way you could create it... Do you need to leave?
No, my nose is just...
I don't want to hear about it. The only way they really created electricity for a long time was just to rub two objects. Okay, so when we talk about, actually the word electros, do you know what amber is?
Yeah.
Okay. Amber, the reason they figured out electricity, the first ways they noticed was that when they rubbed amber on their clothing, it would create a static charge. So everything on down the line, all the electricity we run with first, now we don't need to rub objects to get that electricity. Now we know how to have generators and how to have batteries and all that stuff. But it all started with just the fact that we noticed when we rubbed objects we got electricity. Okay, and later on they figured out that's what lightning is. And later on they were able to create a battery. And later on they were able to create these generators that we have now. But it started with just the idea of rubbing two objects. Okay. I don't care about that. This is the equation you need to know. The force between two objects will be equal to some constant, K, that will always be the same number. This K right here. You don't have to solve for anything else. You will know that K is always 9 times 10 to the 9th. Always, 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 always.
What should we write down?
What should you write down?
Yeah.
I'd say the whole thing.
The whole thing.
Yep, all of it. Okay? Force equals K Q1 Q2 over R squared, where R is just the distance between the objects, which are the two charges. K is a constant, 9 times 10 to the 9th. And this talks about how strong of a force two objects have between each other to get pulled towards each other. Okay?
Nope.
That's Coulombs law. So we'll pause there and let you copy it down. We'll pause there.
This is correct.
Yeah.
Okay. Now, you hear a lot of things about cell phones at gas stations. Have you heard that could cause an explosion? That's kind of a myth. Now, I wouldn't go around and just make phone calls all the time next to the gas station pump, but really that's not going to cause it. There's not enough static electricity with that. However, there are a lot of gas station explosions. And the idea is really more, it's going to happen more often during the winter. And the reason for that is one, the air is going to be drier. The air is not going to be as humid during winter. Okay, so that means you'll get more of those shocks. Kind of like during a winter day, it's more likely when you ever shot, if you shock yourself walking across a living room, it's usually during a winter day. Also though, on those cold winter months, you have drier air, but also your car can have a different charge than the pump. Okay, remember that your car has the big rubber tires, and that insulates. Okay, so you can have a car that has a certain charge, and the ground and the pump and everything else have a different charge. Okay, so what happens? People will go in, they go in their car when it's pumping, they sit in their car, and then they get out. Well, for one, your butt's rubbing against the cloth seats, but rubbing in and rubbing out, when you go outside and people go to grab that pump handle, that's where you get the spark. And you got all the gas fumes coming out right there. Okay, so that's where you see these. That's where you see these gas station explosions happen. It's going to be on cold. It's going to be more likely on colder days, but can happen on a warmer day. And it's going to be because you go in your car and go out of your car. So just understand this: anytime you're at the gas station, anytime you're in your car and your car's pumping, and then you have to touch the handle, just tap the hood of your car first. Okay, just if the pump's over here, just get out of your car, tap the hood, and then go over it. So that you can ground much further away from the fumes and from the pump. Alright? Because you will. It happened today or this year to me, like in the springtime. It wasn't too hot, but it was just apparently just much drier air. And I felt a shock and it was on the handle. But it was further down, fortunately, and it didn't ignite any fumes. Okay? So you need to be very, very careful with that when you're pumping up your car. That you will have a change in charge. Yes, sir?
Does it actually explode or does it just light on fire?
It'll explode. If you have all those fumes, that's an explosion. You hear a lot about gas station explosions. It's also going to be the case, let's say if you need to have those extra gas cans, let's say you have to go fill up a gas can to mow the lawn. You'll see people that will put them in the back of their car, have the gas cans, and let's say you have a pickup truck. You put it in the back of your pickup, you go to the gas station, and you leave them in the back of your pickup when you fill them up. Your car will have a different charge than the pump. Okay? Driving through air, okay, it's going to create, as you're going through that air, you can have your car be charged. So what happens, again, because those tires, you have big thick tires that are insulating, the car has a different charge than the pump. And when people have brought the gas pump to those little gas cans, those little red gas cans, you get another spark and an explosion there too. Okay? So anytime you have to fill up one of those little red gas cans, always, always, always put them on the ground. Okay? Because if they're on the ground, you know that now they have the same charge as the pump that's in the ground as well. And then you won't have that explosion. Okay, but I'm dead serious. You want to be careful with that. It happens a lot, gas station explosions. Okay? Alright.
I dance in my car when I'm
What's that?
pumping.
You dance?
Yeah.
Yeah. So that's going to
Pipes
be
and stuff.
getting a little bit more static charge, yep.
Drinking with my subs turned up, so that's probably creating some static too.
I don't think the subs are doing much.
They're throwing me around in the seat.
Okay, there you go. If they're throwing you around your seat.
But
Okay, we're done. You can stop.